Hello, this is Mr. Newman again, and in this video I'm going to show you how to solve two different kinds of problems with the law of sines. Now in this situation I give you two angles. I give you angle Q and angle P, and I also know that side Q, which is opposite angle Q, is 9 inches, and we're looking for side P. So notice that we know opposite sides and we're looking for opposite sides. So this is a great situation to use the law of sines. Let me put the law of sines up here really quickly. So as I mentioned in the last video, we need the sine A over A, we need those to be opposite sides. So I'm going to fill out the two sides that we do know. This would be sine of 133 degrees over 9, and that's equal to sine of 13 degrees over its opposite side, which we don't know, which we'll name as P. Alright, and now in this case it's just an instance of cross multiplication. Okay, we can use that to solve these two fractions, so let's do that real fast. We have on one side we've got P, we have P times sine of 133, and on the other side we have 9 times sine of 13 degrees. Now when we divide both sides by sine of 133 degrees, we get P by itself and we can figure out what it is. Sine of 133. Now if this previous step you could have just plugged in sine of the 133 and sine of 13, you would have gotten some numbers, and if it's easier for you to solve that way, that's perfectly fine. So I'm going to type in sine 9 times sine of 13 divided by sine of 133 into the calculator, and now I get that P equals 2.768, and I believe that is inches because that's a distance. Alright, now for the next problem, we now know two sides and one angle. So I'm going to use the same equation, but this time we're going to solve for theta. Alright, so let's write this down. We have what we know, sine of 95 degrees over opposite 95 is 6, so I'm going to put 6, is equal to sine of theta divided by 4. Now again, I could cross multiply this time, but it's a lot faster just to multiply both sides by 4, because when I do that I get sine of theta by itself, which is one step closer to getting theta by itself. So we get sine of theta equals this whole thing on the left here, and I'm going to type that in the calculator and see what I get. Now you can check me, but I got 0.664, about that, rounded to 0.664. And lastly, to get theta by itself, we just have to do inverse sine. So I'm going to do inverse sine of 0.664, and when I type that into the calculator, I get 41.61 degrees, rounded up to 41.61. And that's theta. If you had your calculator in radian mode, I think you'd get 0.7 something, but either answer is perfectly fine. Thank you.